This tutorial is intended to provide an introduction to radioactivity. Remember that in the nucleus, it's composed of two nucleons, the protons and the neutrons. The number of protons is the atomic number, while the number of protons and neutrons added together is the mass number, or effectively the mass of the atom. All nucleons, protons and neutrons, are attracted to each other by a strong nuclear force. That's actually the name of the force, is strong. Protons repel each other by electric forces, because like repels like. Neutrons have no charge and do not repel each other. The presence of neutrons helps hold the nucleus together, kind of like a padding. Not all atoms of the same element have the same mass, due to different numbers of those neutrons in the atoms. They do, however, have the same number of protons. Keep that in mind. The atomic number always stays the same for the same element. There are, for example, 3 naturally occurring isotopes of uranium. Uranium will all have the same number of protons. However, notice that the mass number is different. That's because of the different number of neutrons. So just so we know some of the terminology, nuclear reactions are chemical changes that involve nuclear particles in radioactive decay. Radioactive decay is the nucleus of elements spontaneously decomposes by emitting nuclear particles, electrons, positrons, or electromagnetic radiation. And the nuclear force is strong force of attraction between the nuclear particles. So let's look at radioactivity a little bit closer. It's a spontaneous decay or disintegration of an unstable atomic nucleus. The emission of radiation, which is an energy, and or the matter, protons, neutrons, smaller isotopes, beta and or alpha particles, and it occurs as a result of an unstable ratio of neutrons to protons in the atom's nucleus. Radioactive rays can ionize matter, which causes uncharged matter to become charged, and therefore it can be detected by the Geiger counter or an electroscope. They have very high energy, can penetrate matter, and cause phosphorescence chemicals to glow. The ability of matter to glow after absorbing radiation is the basis of a scintillation counter. Historically, let's look at some of the main characters. Becquerel discovered that certain minerals producing penetrating energy rays he called uranic rays, similar to X-rays, but they were not related to fluorescence. Determined that all the minerals that produce these uranic rays contain uranium. They seem to produce rays even though the mineral was not exposed to outside energy. Marie Curie used the electroscope to detect uranic rays in the ore samples. In the process, she discovered new elements by detecting their rays. Radium, for example, was named for its green phosphorescence. Polonium was named for her homeland of Poland. Her findings showed that these rays were no longer just a property of uranium and its ores. Based on her experimental work, she renamed Becquerel's uranic rays radioactivity.